Good afternoon, everybody. I guess this is the last session before you go out and having some drinks and enjoy yourselves and talk about the day. I got my colleagues who are joining me, so please, Wael, come in first. Dan Hodges, Jayraj, Nair, and Markus.
We've got a fan club.
All right, thank you. So I was going to ask Dan what's the weather like at home, but he's here with us, right?
I am.
With IoT and AI, we should be able to do that, right?
No hurricanes this week, so we're in good shape.
Excellent, good, good. So basically, before we get started, talking about artificial intelligence, you guys have heard this morning, those of you who are here for the keynote, the first keynote particularly, from Professor Joe Paradiso, talking about the extension of self with all what we have in front of us. So when you think about it from an AI point of view, when we bring the trends between IoT and AI, which is not more real, and we look at some of these aspects, particularly with smart buildings or intelligent buildings, and we look at those topics, first, I want to frame this, and I'm going to start with you, Dan. Tell us a little bit about AI from at 37,000 feet maybe when you're flying. So let's talk to the audience about this.
Well, today's topic is AI and smart facilities, so I thought I would talk about something 50 years old. In 2018 will be the 50th anniversary of 2001. And that was, and for those of you who have seen it, there's a scene there where Hal says to the Dave that he is shutting him down because he read his lips and the mission was in danger. So there's an example from the past.
Yeah.
But when we look at AI, it actually goes back to Aristotle and Socrates. So it's hardly anything that's new. It's just the iteration of it is new. I met with Ray Kurzweil this summer, and I asked him, how do we think about change, and how do we think about artificial intelligence? And what he said was, think of the next 100 years that will be making around 20,000 years of progress in the next 100 years. I don't know if that helps or hurts, but if we look at data consumption, right now we're consuming about 12 zettabytes of information, and that's rapidly growing to 180 zettabytes in just 8 years. So there must be something there. Apart from 2001, anyone who's been to Disney Paris, Disney Shanghai, or Disney World can see artificial intelligence at work. When you're a guest at the Disney parks, they're always anticipating your next move. Uber is an example of artificial intelligence, as well the prior panel with Southwest Airlines. So I hope that paints the picture.
That's a good start. What I'm going to remember is 100 years in 20,000 years of progress.
20,000 years of progress in 100 years.
So a year in 200.
Yes.
That's unbelievable. So you guys maybe we'll have a few minutes later. Think about that question you want to add to Dan. So Markus, I'm going to come to you. So if you were here this morning, you've seen a lot of the questions that were related to a number of components that come together. Billions of sensors, you guys who are here, you've got a lot of sensors, a lot of devices on your phones and other things. When we think about buildings or facilities in general, which could be anything, an airport, a hospital, a campus, a number of us were in India a few months ago looking at a couple of those. So these things are interconnected and they need to collaborate. So when I look at a lot of AI algorithms, they're seen as black boxes. You give them inputs, you get outputs, but most of the time you have a lot of challenge. You'll have a hard time trying to get them to explain to you how they are doing their reasoning. And that's a big issue. I think, Markus, you can tell us a little bit what's needed there. How do we get these components to talk to each other?
First of all, thank you for being here because I saw a lot of parties outside already, and thank you for staying here for the panel discussion. I would like to give you an example which comes more from the automation industry. There you have some sort of automation pyramid which consists of 4 layers, in fact. The first layer is the ERP system, then you have the MES system, the process control, and the machine control. And the issue which exists as of today is that all these different layers have different data communication solutions talking to each other. So this is really an issue, since You need to have gateways in between these layers, and this is really expensive and a bit complicated as well. Over the history, I think there are now about 15 different field buses, real-time Ethernet solutions, which are some sort of proprietary solutions. So what's the general solution for that? Well, in fact, the only organization that defines Ethernet standards is IEEE. So there was an initiative started, thinking about 2012, which initiated TSN, which stands for Time-Sensitive Networking. And within that initiative, many companies like GE, Cisco, Broadcom, so many companies worked on that standard. And now that standard gets really reality, and all the substandards are going to be released within the next months, or, well, within this year probably. To get this kind of standards really running and to get some sort of conformance test, there are other organizations taking care of that. So the Avenue, for example, is taking care of the conformance test. But then ISC also comes into play here, which is extremely important. And there's the testbed out there, which is the TSN testbed, which has been awarded as the best testbed within ISC. And there are a lot of companies, in fact, 23 companies provide their components interconnecting with each other, and some of these companies are competitors. So what's the result, or what I wanted to say is we have organizations in place that take care of the standardization, take care of the conformance test, and also take care of the interoperability of these standards. And I think this is the right way of getting forward to have this pyramid, in this case, dissolved, and having all these different components, they are then able to talk to each other. And I think that's one of the main assets of putting the communication between these.
Thank you, Markus. So you're inviting our audience to go see the TSN testbed, right?
So it's out there.
Okay. And you'll be there
tomorrow and the day after. You're welcome.
You'll be there to answer questions. Great. So we're an IoT conference here, and driven by solutions. But before I go to you, Jayraj, I want to ask Wael a question first, right? So how do you relate that to other aspects of IoT, big data, and a bunch of other things that are really important when you bring AI into the mix? Yeah.
That's a really good question. So first of all, I want to also add my voice to my colleagues here. Thank you all for joining us so late in the afternoon. It's an honor to be up here on the panel. I think, to me, there's a phrase that I like, which is, big data, analytics, and IoT are three sides of the same coin. I think a lot of people look at, what the value is of the IoT system. Well, of course, without the technologies that Markus just talked about, being able to collect data in real time, act on it, and process it, we wouldn't be able to do anything. But the real value here is about getting insights out of the data. And to get insights out of the data, you need to look at analytics. So some of the activities that are occurring adjacent to, I would say, the IoT sensor networks, I would focus on two things. One is the analytics, and the other would be the big data. So let's dive for a second into each. I think on the big data side, one of the changes that we see moving forward is, rather than just make it bigger and faster and put whatever data comes out into the system, we are instead saying our compute technologies that we should be building and using need to be tailored to your data sets. So a very common example that I use with people is to understand how data sets are different. How many of you have ever been to CERN in Switzerland, the Big Hadron Collider? Okay, it's really cool. If you haven't been, I would highly suggest that you go. So at CERN, they spend months preparing for one experiment. It takes less than a second, and they collect tons and tons of data that they then, here's the key, they then study for years. So it's highly persistent. On the other hand, think of like a major city like Manhattan, right? Take all the data that comes out of the traffic systems. Well, that's great. but it's not very useful an hour later because the traffic patterns have changed. So the compute systems that you need around this, whether it's the storage, the processing, have to adapt to the data sets that you have. On the analytics side, you know, as you mentioned, analytics has been around for a long time. But now we're seeing the applications within the different verticals. And one of the things that you look at in manufacturing is, okay, can we have algorithms that are adaptable to the data streams? Can we train them? And some of the techniques that are coming up are things, you know, I'm sure you've heard the buzzwords, machine learning and deep learning. And this comes down to, you know, what algorithms we use, how we train them, what models we can look at. And it's a lot harder of a problem than people anticipate because you also don't want to get it wrong. And you want to be able to figure out if you are getting it wrong. So in my view, I think big data and analytics are two of the areas adjacent to AI that I think we are going to see a lot of innovation around.
Thank you very much. So Dan, a minute if you want to add to this. Yeah.
There's just one fact, and we talked about this on the phone, but only 0.5%, I'll say it one more time, only 0.5% of all data that has been created has been analyzed. So there's just a huge opportunity to do what you said. Yeah.
Yeah, thank you. So Jay, I'm going to come to you with a big question. So you and I travel a lot, and we travel together around the world to visit a lot of these very challenging areas to explore how we can use IoT and bring AI, and as well mentioned, how can we enhance analytics with capabilities that would come from artificial intelligence, right? So, you know, as a big SI as you are, and with your role and your leadership, you've seen this with a lot of customers. So this is a solutions conference. We want to understand, our audience is here to kind of learn about some examples. Go ahead, talk to us about some of those. Yeah.
Thank you for the opportunity, and I'm sorry I sound a little different. I got a little bit of cold, but this late in the day, nothing matters. But thanks for staying, especially when the beer is out, as Markus pointed out.
There's some water for you.
Oh, I got some of my own, thank you. So I think I'll take your point as a lead point. 0.5% of the data is analyzed. It all eventually boils down to analytics and insights, right? So analytics and insights are the cornerstone of what you want to do with all the data that you're acquiring. And data acquisition at the edge, in terms of the volume, the velocity, it has only gone up, and it'll continue to go up. How do you make sense out of the data? What do you do with it? I think that's where we have also struggled quite a bit in terms of real-world implementations. One of the, so Wipro does have its own assets as well. So we have an AI engine. It's called Holmes. It's related to Watson in some way. But Holmes has got bots, again, algorithms, supervised learning models. You get training data, you educate the model, you refine it, you have test data, and then you kind of create more and more insights. So we've gone through that phase. I think I'll use two examples. One is the deep learning testbed that Saeed and I've got the opportunity to work together on. This is with Toshiba and Dell EMC, and it's actually deployed in the Kawasaki building in Tokyo. So Saeed, if I get the numbers wrong, it's like 35,000 sensors, right?
Yes, yeah.
It's a greenfield environment. It's not, Joseph, you've been to that event, to that building as well. It's a greenfield infrastructure, so it's got a lot of latest and greatest sensor technology in it. So it senses, detects a lot of characteristics, environmental factors, again, energy efficiency kind of metrics, all indicators that can lead you to increase the efficiency of that building or to improve the quality of life of a person who's within the building, be it the escalator travel time or the wait time. So to do all of that, you need something at the back end which ingests all this high velocity, high volume data, and it has neural nets in place, multiple layers, deep convolution network. Yes. The inferences that we have seen it make, or the deep learning testbed make, have been reasonably good. Yep. It has actually pointed us in several instances, at least in the last quarter when we looked at some of the results, where it has pointed us to real predictive failures. Yep. So if you look at maintenance efficiency as a set of use cases, it has actually helped come out with some good metrics and good results. So that is one test bed. In fact, it's in the Industrial Internet Consortium's website. So you can go and look all the details of what the test bed entails, the use cases, and we can do that.
Yeah.
The other area where I think we are working a lot on is around image analytics.
Yes.
Like, especially if you take an asset management scenario and you take, again, the maintenance is a very good use case, predictive maintenance use cases. And you have cameras mounted that actually look at the sidewall of these big excavators and loaders and dumpers that are running around in an open pit mine. And then you take, say, 10,000 images and then train the model on what is a defective situation. What kind of a cut on the sidewall of a tire can lead to implosion or explosions, right? And then that can help you predict failures in a better way. So supervised learning deployments are starting to happen, but I'm sure, I think the compute storage and networking technologies at the edge is getting more and more exciting. I mean, so many chips are there now that can do a lot better SIMD processing at the edge.
Yeah.
So I think we'll get to see more better implementations where you have some kind of long cycle analytics at the back end and some short cycle analytics happening at the edge.
So Jay, you're seeing some results already with those where you can see the difference by enhancing the analytics that you would do without AI. So by adding AI, you're enhancing it a little bit more, particularly like you said with the Kawasaki building where it's unsupervised learning, meaning the system is capable of doing that on its own. Thank you. So Markus, I'm going to come back to you with another question. This morning, Richard Soley in his opening remarks talked about how important it is to have security and privacy, data protection in general, in order to enable some more success, or at least take the industrial internet to the next level. And I believe with this topic we're talking about here will be the same. So how do you address that? What's your opinion?
Well, I think one of the most important aspects is where I place my data.
Yes.
So let's assume, well, coming back to the original setup I used here, a machine builder and a machine user. A machine builder obviously would like to get the data of all the machines that are running on a global scale. So get the data because they do the maintenance for that. They would like to know the weakness of particular parts of the machine. So they need some sort of cloud where there's all the machine data. The owner of the machine has a completely different motivation. They would like to have the production data, the quality, whatever. So these are two different set of data which can be somehow divided in a cloud with a role-based model. So all the data is produced by the machine, but the view on this kind of data is a different one. If I talk to people where we have projects with, they say, well, we do not want to share my data or their data at all, and they somehow a little bit reluctant about sharing data. So it also depends on the country where the machine is. They really would like to keep their data in a factory or in a local area. So not in the cloud, but on the edge or in the fog or however you name it. So you have data in the cloud, data in the fog for different reasons. Another reason could be you have a power station in the middle of the jungle and there's no working internet connection. So you also have to place the data on a local cloud. And then there could be some issues with the machine or with whatever, where you have to react in a very fast mode within milliseconds. In this case, the data is not stored on the fog, on the cloud, so the data then is locally used. So in some sort of PLC-like or IPC-like hardware boxes, you can store the data, and these boxes can be attached to the machine itself to react in terms of if there's a certain minimum or maximum reached that you can react directly.
Great. Thank you. Thank you. I'm sure we'll come back. Maybe our audience will have another question for you. So I want to come back to you, Wael. what is the IC doing in this area? There's work, I'm pretty sure you can kind of give us some examples. Yeah.
That's a great question. I thought you'd never ask. We have, so a few of us here have also participated in IIC. And one of the nice things that IIC does is it has a number of deliverables, from white papers to what we call technical reports, commonly called industrial IoT something framework. And what we try to do is pull together an overview and a set of requirements around a particular topic. So in this case, I mentioned earlier that analytics was one of the adjacent fields that, to AI that we're looking at. So within the Industrial Analytics Task Group, earlier this year in March, we published a white paper that looked at the treatment of analytics within the industrial IoT. And by the way, I should pause to mention that within the IIC, we use the word industrial not to mean manufacturing, but in the global sense of the word, which is multiple different industries. And the white paper did a treatment of everything from what is the analytics to what business value it brings in, what are some of the considerations that you would look at, down to what some of your design constraints could be. So for example, we've heard from Markus, things about how the latency may be very important in certain applications, so in which case the analytics could sit closer to the edge. In other cases, the data may be persistent for a while, so it could be in the cloud, and you have combinations of both. So that was published back in March. I encourage all of you to go to the website for IIC and download it. But even more exciting is we took that work and we expanded upon it into what we're calling a industrial analytics framework. And that will be released hopefully within this quarter. And one of the things that we did is we went back and said, how's a more structured way to think about this problem? And we told ourselves, okay, we have our IIRA, our reference architecture, which has been highly successful. And that builds upon ISO IEC IEEE 42010. If you could say that again, I'll buy you a beer. But that looks at system, architectural frameworks. And within that, it takes different viewpoints. So our reference architecture does that. It looks at a business viewpoint, an implementation viewpoint, and so on. We did that for analytics. And here's the exciting bit. We then added some things that are emerging initiatives in this area that are exciting. So we have one chapter that's going to be talking about artificial intelligence and big data. So I already talked about big data. And under AI, we go into the differences, we introduce and then go into the differences of deep learning and machine learning. But we also added other things. For example, we look at how you could select different algorithms, how you could look at the modeling aspect, what some of the constraints are when you're thinking about this. And we finally tie it off by saying, okay, as an example, here is a look at manufacturing to see what different standardizations across the entire business cycle that can be used. So I think when this comes out, it'll be an exciting read. It expands on the white paper, which you can download. And last but not least, I just want to give a shout out. One of my co-authors and co-chairs is in the front. So I'll be happy to take any questions. And you can reach me at eric.harper@abb.com.
Okay, well, I'll leave that between the two of you, okay?
Exactly.
So when will this paper be ready, just so that people would know?
So the white paper was published in March. That's available. We're targeting a publication sometime in October for the framework. It's in.
Now, let me ask you a hard question, though. If I was sitting over there, I would say, what do I do with this paper? What do you think? I mean, what solutions can I, how is it going to inspire me?
That's a great question.
Yeah.
So I think I think we have multiple audiences for these things. So if you're thinking of deploying an IoT solution today, right? Then one of the things that's got to be on your mind is, is this gonna be right for me in a few years? And the answer is maybe. So take a look at what your requirements are and what technologies are available to you or what technology considerations you need to go through. And that is really what the white paper does, is it lays out whether you're coming at it from a business perspective or a technical perspective, what the different things that you have to think about as you think of this emerging field. And the framework expands on that and goes into a little further detail into those.
So you'd recommend that for people to read the paper and have conversations internally between the business and the technical people, the architects, et cetera, and start figuring out potentially some new innovations, services. And I know Jayraj knows where I'm going with this. Does that make sense to you?
Totally. I would just add one little thing, which is it's also to get your IT people and your OT people talking to each other.
Right.
Because part of the issue here is that the IT world has been moving, as you mentioned, for the last 30, 40, 50 years on this, and the OT world is changing in what the business requirements are. So I think getting that conversation going in your company is very important, and taking a look at some of the requirements that we lay out in the white paper or the framework may help you with that thinking.
Very good. I appreciate that. Thank you. So Jay, I'm back to you. You're never jet lagged, are you? Never, right?
No, you don't have time to get lagged, right?
So you're all over the place. You're you have already the extension of yourself, as Joe was mentioning this morning. So let me ask you, so you meet a lot of customers.
Yeah.
What do you tell our audience? I mean, what examples they need to look at? What's their expectation for the next 6 months, 12 months? Think again, put it in perspective. We're talking about AI and smart facilities, and that could be anything, right?
Yes. So I'll
And you want them to be as successful as you, please.
No, but with Wael's comment around the IIRA document, I think as individuals and as companies, when we engage with customers, it is always good to not just have your own point of view, but also look at what the industry and the ecosystem is doing. So documents like these, the IIRA document, or even with Industry 4.0, the RAMI architecture, all of these architectural constructs help you get a ecosystem view into the mix. So it's not just your own individual point of view. So it validates the solution across all the fronts, all the use cases, the reference architecture, the actual stack ingredients. So it is good to work and read and download and understand. And it helps us deploy solutions that can actually sustain.
Yeah.
Right? So I'm a big fan of the consortiums that actually work on it, because it's a lot of selfless work. A lot of these guys, Eric Harper's name came up.
Yeah.
They all work on.
So Jay, this morning there was a keynote from Schneider together with Deloitte, giving us an example about how innovation can be driven from the openness of the architecture and leveraging these types of frameworks and ecosystems, right? So that's where you're going with that, is it?
Absolutely. I think solutions that are more open-ended, the ability to integrate multiple viewpoints, are the ones that are sustainable. IoT is an ecosystem play, so that's a statement that you hear from literally everybody in this space. You got to work with different players at the edge tier, the platform tier, at the enterprise tier, especially now with more and more focus on the analytics, insights, the AI, the ML capabilities. Not all of these are mature at the same
So let me
level
add
of
something to
maturity.
your list, if you don't mind. So when you go into AI, you're going to see a lot of frameworks, right? And the majority of them are open source. Any one of you can go and download those and use them. So how do you bring that into the mix, into what you're talking about?
So thank you for correcting me earlier about the Kawasaki building, unsupervised learning versus supervised. Most of the deployments I'm...
Please note, we are closing exhibition flow 15 minutes early in order to give you time to get to the metro with the shuttle buses before 8 p.m. when both services end for the evening.
Okay, so we got the message.
You got the message. I
One
didn't
last,
want to overrun
one last.
that.
So you finish your comment. I would like to give an opportunity to
Open
the audience to ask questions. Yeah.
My comment is that I think work with the ecosystem. Don't just be bound to our own ideas. As an SI, we get to take every partner's pitch to the customer, and that is an agnostic view that we have the privilege of having because we are a systems integrator, right? So we work with literally everybody. There's no agendas or no politics involved. The customer is king. They tell us what they want to deploy. So I think having that open mind, looking at open source, I think Joe Paradis, even Cyril pointed to some good solutions in the morning. Please follow that guidance.
Excellent.
My request, if there's one humble request to this audience, is look at what Wael said, right? The IIRA document, the security reference architecture that the team has published, the ISC team has published.
Yeah.
Look at all those and give feedback. Give candid feedback to the authors saying, you know, you're missing this, or please include X or Y, and we'll make improvements in it.
Great.
Back
Thank
to you.
you. So why don't I give the opportunity? Do we have someone who can pick questions? Do we have a microphone somewhere? Any questions from the audience? No?
The
Wow, everybody's
easy
shy
ones at the
today.
end of the day, right?
Mr. Smith, yes, please.
Calvin's got a question.
Well, talk to me and I'll ask the question.
No, there you go.
Oh, here we
That's
go.
fine.
Here you go. We got it. Yeah. Thank you.
Yeah. Testing one. No, it's not. That's okay.
Is it what? Yeah.
Oh, yeah, there we go. Thank
There
you
we
so
go.
much. So this is a tough one. So anyone that wants to answer it, right? Taxonomy and taxonomy and ontology and these kinds of things are always a little bit difficult. But you know, if you ask someone to define IoT, you get 10 somewhat similar responses, at least somewhat similar. But tell me about the differences between ML, DL, and AI. How can we dispel, what are the borders or boundaries that actually differentiate these groups of technologies?
So I would say if you read the industrial analytics framework when it comes out, we have a chapter just on that.
But that's a good question, though. I mean, there is a lot of vocabulary out there that's thrown at us, and a lot of people think of it in terms of, is it a buzzword, is it real, what's true, what's not, what's out there, et cetera. So maybe, Dan, I would like you to take a stab at this and
maybe
help us.
a good example of that, a practical example, not a theoretical example, is the Coke supply chain. So Coke looks at...
Dan, can you bring your...
Consumers look at vending machines, but Coke looks at sensors.
Yeah.
So what they basically do is they take various factors into control: location, temperature, history, and also each individual data point's history of the display. So if Saeed, if your kids are playing soccer in Dallas and the temperature gets above 80 degrees and the Coke machine gets below 40, it sends a trigger to the supply chain, which sends a trigger back to the factory. And everything is automated. There's no phone calling, you know. And so I think that's an example. And Coke has actually, their whole global system is real-time AI. So,
Okay. Another question, yeah, please.
Hi, I'm Samir Vyas from Wipro Digital. One of the questions that I always get asked from customers to whom I'm evangelizing the value of analytics and predictive analytics and all that great stuff, once they are wowed with what is the art of the possible, is that they all acknowledge that the data that they have is not trustworthy. It's not clean enough. So no matter what kind of analytic solutions, you can have the Mercedes-Benzes of analytics technologies applied to it, you're never going to get anything more than garbage out, basically. That's their concern. So how do you get such organizations who want to make the big leap, who want to become more data-driven, but they shudder or they hesitate to take the first step because they feel that unless they get the right kind of data, they won't make that change. So what do you tell to those customers?
So is that a question for me?
Who wants to take a
to
stab
anybody
at
who want to take up?
this? Jay, maybe that's...
Yeah, he's from Wipro, so we kind of hashed the plot before we got in here, right? No, seriously, this is a surprise. But I think the ETL, data cleansing, normalization, all those upstream processes before you start indulging in very high-end machine learning algorithms to kind of predict the future is a good thing. And I think there are sufficient tools and technologies out there today to demonstrate how you can cleanse and normalize the data, correct and make it trustworthy with either a functional stack viewpoint or a smaller scope and size, domain level viewpoint. I think all of those things are possible today versus a few years. If you look at even the open source world, I mean, look at our own platform, the DDP platform, the data discovery platform. I think orchestrating, understanding the context and the metadata associated with the data itself is a phase that you have to do before you get further downstream in this
So
path.
Jay, that's a problem that needs to be solved.
Yeah.
For those who are here and maybe they're thinking about a startup or a new business unit, et cetera, this is an area where
There's a lot of opportunity
there is a lot
in
of
this space.
opportunity to
Absolutely.
drive
I think there's an opportunity in every one of these spaces that we're talking about.
Yeah. And I would say beyond, and then, well, I'm going to let you, we got 1 minute left, so I would like you to comment on that as well as Dan.
I think Jayraj, I completely agree with Jayraj about on the data side. I would add two quick comments. One is, I think also on the model side is part of the problem because there's an entire field of just how you train your models when you put them into the system. And it's very important to make sure that the model is actually spitting out something that's valid, or when it's seeing bad data, you can tell the difference between the model failing or the data is bad. So that portion of it is I think critical, in addition to cleansing the data and all that. And then the other thing is, again, we talk about this in the industrial analytics framework. Please download it and read it when it comes out. So,
Great, thank you. So
we have got a final question.
One more question.
one final question, please, quickly.
Hi, Leonard Lee, Next Curve. The question is, in the context of IoT, why do you need AI? And what are maybe the 2 or 3 or 4 or 10 or 20 outcomes that AI would enable in a IoT solution? You know, and these could be just generic things, but you know, the question is really why.
That's a very good question, absolutely. So let me take a quick stab at this for a second, okay? So I've seen examples where you're looking at billions of data points with multiple thousands of processes in factories, for example, and they are part of these facilities, where typical data science cannot deal with them, where you need to get to the next level using deep learning, for example, or other types of AI technologies. Think about some of the examples that you hear about these days, like the image processing and some of the latency issues that Markus was talking about, where you need to get to that level. And with IoT, as you probably heard this morning, the numbers are just going to be growing. So not only the numbers in terms of data, but the numbers in terms of the assets and the sensors and what you'll have in front of you. So that's one answer. I may be wrong, but when we look at, I got Joseph here with us. He's been and visiting the test bed that we're running in Japan, where we have 35,000 sensors, as Jayraj mentioned, but remember, those are capturing data every minute, and you want to be careful what data makes sense to you, what's relevant, what's not. And that's where you need some of these additional algorithms to support you to that question that Samir was asking, making sure you're cleansing the data, making it trustworthy. So that would be one approach to it. But I don't know if Dan, maybe you want to comment,
I mean,
and then we can end where.
Maybe example, not a Coke example, but is UPS. The CTO of UPS spoke 2 weeks ago at Mobile World Congress in San Francisco, and he said that he's an analytics company. Now, after I got off my chair, I said, well, don't they have these brown trucks and drive around? He says, no, we don't look at ourselves that way. So they've actually redefined their business as an analytics company first. And that is informing the supply chain.
Exactly.
And they have so many variables. They've got weather, mechanicals, logistics, demand. The Christmas demand is different from the September 30th demand. So they've defined themselves as an analytics company, but before they were a delivery company.
Yeah, thank you. I think we run out of time. I want to thank you all, and please join me in thanking our panelists. And feel free to reach out to them when you see them on the floor. Thanks again. Appreciate it.